Hi guys, welcome back to the channel. So we are starting a new series in which we are going to discuss about class. So many of you might know and might not know about what is class. So let me have a brief introduction what is class and what are the things that we can do with class. So class, as the name suggests, it says cosmological linear anisotropy solving system. So class is a package, is a Python package, like you can use it in Jupyter notebook to work out with cosmology. So like we have different composition of dark matter, and we have different composition of ordinary matter, boryons and all these different stuff. And to simulate it, we can use class, because like there are tens of equation that we got, like Boltzmann equation. So class helps us to solve those equation, taking the input as these different densities of this different constituents. Okay, so in the implementation part I will like explain those things, but like here I can say that class is a very fundamental software that has been used by cosmology people to simulate different cosmological models here. Okay, so you can download this file class 2 on your like local system, or you can simply say pip install on your Jupyter notebook to like avail this thing, and you can import this in your like Jupyter notebook. Then here is the like whole, I will put the link of this website in the description, and this is the official website of class. You can just follow up this and get like install this on your own system simply. Yeah, that's a simple thing. And let's like, if you want to go in the literature detail, you can go on to these, you can like look into these papers. So like they have explained all the equation that they are using, like the all the Boltzmann equation, all the approximation that they are using, they have like described it. Okay, so like they have described our class, how like we code up. So H here is the Hubble constant, T CMP is there, omega B, these are the densities that we have. Okay, so like on the way I will going to explain all of these things. And yeah, so let's like talk about the basic structure of class, what is behind the class module. And this will be helpful when you are like going into the package and modifying the Boltzmann equation, modifying the intermediate equations that are there. So that would be helpful if we are like consider knowing the structure of the class. So class is like 11 modules here, 11 directories that we can say, and they follow like a sequence. So the first is the input, then the background, then the thermodynamics, then perturbation. So like what happens here is we provide some input in the input.c, then it takes in the background information, like puts in the background information of that particular system. Then if we want to introduce some thermodynamical like thermodynamical uh, some thermodynamic parameter, then we have to go to this thermodynamical dot c and then see that what changes that we can have, what are the functions that are defined here that we can do. Okay, then we have perturbation, which type of perturbation we want to consider, scalar, vector, tensor and all those things. So like it goes in a flow, and it helps us to introduce new complexity to our system by adding up these small changes. Okay, so like these modules help us if like we have changed something in background.c, or we have say changed something in thermodynamics.c, it will be passed on to the calculation that will be taken up in the like coming other parts in the bottom parts. Okay, so that is a great thing about like using class. So you have to make changes here, and it will automatically make the changes in the coming like modules and all. So after passing all of these 18, we get 11 like files, 11 like modules. Then we end up at output.3, where we get these power spectrum and all those output things that we can observe about the system. And we are like going to see everything in detail in the coming series. So this is like a very introductory video, like I'm trying to explain what is class, then we will move on to the actual implementation thing. And like this is the first paper which like describes simply what is class and how it works. Okay, and see what are the parameters we have here in the background dot c. Let's see. So in the background dot c, like there is a very proper documentation that is available here. You can like go into it and find this stuff yourself. That would be great. And let me like move on to the interesting stuff here. Okay, let me show like here you can see we have background at z. So these are the parameters that have been defined, and it will help us to calculate all of these things, that like incorporate all of those, like the perturbation that we want to give. So these are the various add-ons that we can do to our system apart from the input files. Okay, like we have in the implementation thing, you will get to know about this. So these are the like different parameters that have been defined here, different functions that have been defined here that we can use to add on to the complexity of the system. So like each of the C file is around like 2 to 3,000 line of code. So there's like class software has been very comprehensively coded up. So it's great to know what are the parameters we have in each module. It would be hard to like go through each one of them, but we'll take into account the basic parameters that we have. So these are the like function that we can use. I think that's all from my side for this video, because it is like the first video and it is like introduction video. And in the coming videos we'll talk about the actual implementation stuff. We'll go into the Jupyter notebook and type out some models, code in some models, and let's see how the TT plot looks like for us. Okay, so see you in the next part. Bye.